Hi theory students. Today we're going to be completing our review of intervals. In this part we'll be talking about inversions of intervals, we'll be talking about compound intervals, and I'll also give you some shortcuts to recognizing intervals quickly without having to go through all the calculations. First, inversions. An inversion is when you flip the order of which pitch is above and which pitch is below. Physically, you can think about doing this by moving one of the pitches an octave so that it crosses over or under the other pitch. With inversions, there's what we can call a rule of 9. An interval and its inversion number add up to 9. That means that when it's inverted, a second becomes a seventh, and vice versa, a third becomes a sixth, and a fourth becomes a fifth. Let me show you what I mean. So here on this staff, here are two notes that are a second apart, F and G. If I want to invert it, I can take the F and bring it up an octave. So this is a second, that's a seventh. Notice that the two numbers equals 9. Likewise, if I wanted to do that for a third on the bass staff, I could take that A up an octave, so now it's higher than the C. This is a third, this is a sixth, and together the two numbers, when I'm inverting them, add up to 9. I could show you the same for fourths and fifths, but you get the idea. The quality of the interval changes as follows. Perfect stays perfect. A major interval becomes minor, and vice versa. So if it's major when we invert it, it becomes minor. If it's minor when we invert it, it becomes major. And diminished and augmented likewise when we invert them. They trade places. I'll show you some examples of each one. So here, I've got a perfect fourth. When I invert them, and just to show you, I don't have to bring the F up, I can bring the B flat down an octave. When I invert them, that's a fifth, and it's still perfect. Perfect becomes perfect under inversion. Here, I've got a major third. When I invert this, it becomes a minor sixth. And now I'll show you this is a little trickier. That's a C sharp and a B flat. That's an augmented second. If I keep the C sharp there and move the B flat here, that's a diminished seventh. So that shows you how under inversion, perfect stays perfect, major becomes minor, augmented becomes diminished. For compound intervals, these are intervals greater than an octave. They follow what we can call a rule of 7. That is, a ninth is really just a second plus an octave. a tenth is a third plus an octave, an 11th is a fourth plus an octave, etc. So it's a rule of 7 because the compound interval 9 is 7 more than the simple interval of the second. I'll show it to you here. So if I have a third, and I take that F up an octave, this is a third, and this is in effect a third plus an octave. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and here we are. When we get to the top line, that's a tenth. So the rule of 7 is a handy way for you to compute compound intervals, intervals greater than an octave. Now I'll show you some shortcuts, and we'll start with the shortcuts for fourths and fifths because that's the most consistent one. If the accidental is the same for each note, it's a perfect interval, with one exception: any combination of B and F. For a fourth, F to B flat, not F to B, is perfect. And for a fifth, B flat to F is perfect. So for the exception, when the F is one accidental higher than the B, the fourth or fifth is perfect. What I mean by that is F sharp and B natural is also a perfect fourth. And likewise, B and F sharp is a perfect fifth. So here's what we mean. Let's take a pair of notes, F and C. They have the same accidental, so we'll call that a perfect fifth. Likewise, although this may be more difficult to compute, this shortcut helps us see at a glance that G sharp and D sharp are still a perfect fifth. Likewise, D flat and A flat is a perfect fifth. G flat and C flat is a perfect fourth. I'll make a little more room over here. A sharp up to D sharp is a perfect fourth. Our exception, F to B flat, is a perfect fourth, or B natural to F sharp is a perfect fifth. When I say that the F has to be one accidental higher than the B, what I mean is this. The natural here is one accidental higher than the flat for the B. The sharp here on the F is one accidental higher than the natural for the B over there. So that's what I mean by one accidental higher. The reason this works, think about on the keyboard, C and G are a perfect fifth apart. If I move each one a half step higher, it's still a perfect fifth. So that's why we can match the accidentals, whether they're both flats, both naturals, or both sharps, and still get this to work. For seconds and sevenths, it's not quite as consistent, but it's fairly good. For seconds, if the accidental is the same for both notes, then the second is major. The exception would be the pairs of B and C, E and F. This is a little easier to picture if we look at a keyboard. There's B and C. there's E and F, and those are the pairs of notes where there's no black key in between them. So for all of the other ones, A up to B, there's one black key in between. So we could see that that's going to be 2 half steps or a major second. Likewise, if I take C sharp up to D sharp, you could see that that's 2 half steps. There's one white key in between these 2 black keys. So that would also be a major second. For these exceptions, the B and C, we need B and C sharp to get 2 half steps. We need, let's say, E flat to F to make 2 half steps. So those are going to be the exceptions, the B-C pairing, the E-F pairing. I wish there were a more convenient shortcut for thirds and sixths, but let's try this. Think of the thirds as being in 2 groups. The bead group, we know that from accidentals, and the GCF group. If the bottom note is in the GCF group, the same accidental means it's a major third. So here I'll show you. So if the bottom is in the GCF group, so here's a third, here's another third, here's another third. The accidentals are the same here. The bottom note's G, there's G. Here, the bottom note's C sharp, it's in this GCF group. The bottom note's F flat, that's in the GCF group. Same accidentals, major third. Same accidentals, major third. Same accidentals here, major third. If we were in the bead group, for the bottom note, those would all be minor thirds. We would need to make the top note 1 accidental more, one way or another, to make those major thirds. That's not the greatest shortcut, but that may help you recognize these easier. Sixths are just the opposite. If the top note is in the bead group, then the same accidental means that it's major. If the top is in the GCF group, the top must be 1 accidental higher to be major. The sixths are inversions of thirds, and we know that when we have inversions, major becomes minor, and minor becomes major. So maybe you could help get it that way. That's all for today.